Our next speaker, Dr. Kevin Lim, and he's president and the chief, I think it's technical officer, CTO at Lim Geomatics. He's recognized as an international expert in LiDAR remote sensing, as well as an industry-leading enterprise GIS and IT architect. He obtained his BSc honors from the University of Guelph and his master's in GIS from the University of Waterloo, and his PhD was from Queen's, where his thesis focused on the estimation of forest biophysical properties using airborne LiDAR remote sensing. So, Dr. Kim, all yours.
All right, well, thanks everybody. Thank you for the opportunity from Forestry Futures Trust to come up to Thunder Bay and brief you guys in terms of what we did within our project. So for those who know me, I'm not gonna turn the fire hose on and spray you with technology and whatnot. It's gonna focus really on this KTTD project and what we accomplished in that period. So in terms of outline here, in terms of presentation, I just wanted to introduce you to who we are because we're slightly different in the sense of how we look at forestry. So we'll introduce ourselves, what we do, background motivation for why we initiated this project and perhaps why it was approved by Forestry Futures Trust. We'll look at the objectives of the project. We will also look at the benefits, the partners, the execution and delivery of the project, and then maybe look at some of the success stories and what we're able to achieve there. So this is hopefully in line with what Shelley and I talked about. Again, I'm not going to deep dive into all the boring bits and pieces of how technology works, which is a little different for me, I suppose. And I'll also talk briefly in terms of some future innovation where we can go with that. So just to introduce you, we are headquartered in Ottawa, Ontario. We are a tech company first and foremost, but with about 17 years of domain expertise in forestry. So I myself, I did my PhD in airborne LiDAR and forest inventory, so I'm probably one of the handful that can talk about the early days in Ontario with airborne LiDAR and some fun stories there. We do have presence out west in Alberta, and we're also very active in plantation forests in South Africa, so we can really speak in terms of LiDAR and its application in natural forests and plantation forests, whether it relates to logistics or optimization or planning or a host of different types of forestry business issues. So for us, what we really do is focus on taking data and making it into information products and delivering them through apps. So the days of having a kitchen sink app with 5,700 different functions and nobody knows how to use them, that's changed. You just need to pick up your smartphone and see that whether you're in an Apple ecosystem, a Google or Windows ecosystem. It's all about having an app that does something really, really well. And it's okay to have lots of apps, each doing specific things. So we also learned from history in the early 2000s that we can drop off hard drives, and if they're going to sit there and collect dust, then really it's of no use to us as a community per se. We need to empower the users, the end users, to ultimately do their jobs better. When we hear Jordy talk about 450 hard drives sitting there, that probably raises concerns for everybody, saying, do we have access to that data? And that's no fault to Jordy and his team and the group there. I suppose that was the limitations of technology at the time, but now with cloud and all sorts of other things, there's tons of opportunities. So just to give you an overview quickly on what we do. So we do offer a forestry platform. So I'm not going to talk about AFRIDS in terms of how it delivers enhanced inventories to many people around the world. There's a question online about HRST and LiDAR. I'm sure some of my colleagues that I've worked with, or if they're listening, were probably squirming in their pants a little bit. There is a full LiDAR inventory that has been produced for HRST for several years, so that's been out there for a long time. Obviously, that message hasn't got out to everyone. So we will deal with things like tracking feller bunchers, fleet. Ultimately, it's not about the tracking that it's important, it's about the productivity analysis you can extract from that. Mobile is a big deal, so the concept of how are you going to support Apple, Android, Windows, maybe BlackBerry, they're kind of coming back with a bit of that TCL branded devices. But for all intents and purposes, today's talk will be on LTK. So really, at the early stages, how you convert data into information, and then some of these other things we do take it to the next step. Just to give you a sense of who we deal with and where we're coming from. So here's just a snapshot of some of the players we work with. So obviously Ontario is important for us, but we've gone beyond that, out west heavily into the States, into Latin America, into South Africa, et cetera, et cetera. So certainly the trends of better decision support tools at the enterprise level, eliminating data silos, ensuring users can access data. Those are themes that are prevalent not just in forestry, but across the board in any sector, really. So project background. I've highlighted in green the kind of keywords. It's kind of funny, when I did this, I realized I could probably have submitted a shorter application to the Forestry Futures Trust, but you can scan the keywords. But at the end of the day, in Ontario, there's a rich history in terms of LiDAR research. The names of Murray Woods, the names of Doug Pitt, there's a host of us that early in the day, I would say we pioneered how to operationally use LiDAR data for inventory. So there's a breadth of research, breadth of knowledge, workflows, understanding, but the challenge was that we had people on your side in terms of not understanding how to do it, whether it's too complicated or there's too much white noise, as I call it, things to distract you per se. And then as we kind of went forward, there was new technology coming, so we had not even implemented the existing proven technology. We were now starting to shop around and look at other unproven technology that hadn't gone through the scientific rigor. So the idea here was that we needed a mechanism to support some of these new platforms, whether they're drones collecting LiDAR, whether they're photo point clouds, structure for motion, semi-global matching, poor man's LiDAR, whatever jargon you want to use, it doesn't matter. So we wanted to be somewhat agnostic in terms of what we can do there. And within this context, we wanted to focus on photo point clouds, since the province, as Jordy has mentioned, collects things with the ADS technology. So just a quick LiDAR 101 for those in the room that somehow are not familiar with it. Yes, it's a great tool for collecting information about the ground. You'll notice that, unlike some of my past talks, I've now prefaced this with linear LiDAR. So technology has changed. We've heard about, Jordy talked about single photon LiDAR. You've probably heard about Geiger mode LiDAR, multi-spectral LiDAR. There's a host of different LiDARs that are coming out, which is really, really exciting. This is really old school technology, to be honest with you. It's got different components in terms of an IMU, a laser rangefinder, GPS. The three magic pieces end up allowing you to collect detailed XYZ positions, and that's really LiDAR 101 in a nutshell. You produce these elevation products, DEM, DSM, CHM. So typically, a lot of folks, depending where you go, this is the end of the expert's talk in terms of this is what we can do. We know we can go beyond that. So in terms of purpose software out there, on the right side of the slide are general tools. Some of you have, whether it's QGIS open source, whether you drink the Kool-Aid from Esri, whether you're using Martin Eisenberg's Rapid Lasso tools. Again, there's a host of general purpose tools. But when you really look into forestry and say what is specific to forestry, there ain't much. We've heard mention of Fusion, so Bob McGoy over at US Forest Service and his work there. And then of course we have a tool called LTK that is built for the ArcGIS platform. So that's a differing piece. So in terms of high-level workflows and creating these inventories, again, the slide's not intended to be read as opposed to for setting the context. You collect plot data, you collect LiDAR data, you do a bunch of magical processing, the biomagician takes over and creates a bunch of models for you to use, and then you apply them across the landscape. But what we were seeing was that in that upper box where that star is, technology was changing, and it continues to change very quickly. So whereas in my world when I started, I was maybe 2 kilohertz LiDAR sensors, about 2,000 pulses, and then now we're talking about 300,000 pulses, and with multi-wavelength, maybe 900,000 pulses. Fundamentally, it's collecting point data. So to some extent, how do we address that? And so there's a bit of head scratching there to say, there's a lot of technology that's coming, but ultimately, do we care? The platform has changed. There's subtleties in terms of the differences in technologies, but fundamentally, the output is a point cloud. So certainly with the semi-global matching product, yes, it characterizes the upper canopy, but I was down at Virginia Tech for the Silver Laser event a couple weeks ago. We had a research person from Rainier talking about how they likely weren't going to go that route because they were interested in that complexity, that richness the LiDAR data characterized from the top of canopy to below. Having said that, if you're only interested in just pure inventory, then yeah, maybe the SGM data set will work. So the idea here, coming to this KTDB project, this solicitation, was to really look at developing GIS software that could handle the photo point cloud. So given the investment the province has made in this particular technology, generating the SGM data, could we extend LTK to do some of these things and move the yardstick forward? So in terms of benefits, for folks who are intimately familiar with LiDAR, you know, an area-based approach predicts things on a 20 by 20 meter cell, and then ultimately that's the minimum predictive unit. So how you roll that up to what spatial fabric, that's really up to you. So this is why we say it can support a strategic level, inventory can support an operational level planning. We saw in the last speaker an FRI polygon that got sub-broken down into further stands based on quality. Those are all instances in terms of how you might leverage a LiDAR inventory, an area-based LiDAR inventory going forward. There is also interest in terms of extending the software, extending it, but ultimately leveraging a lot of know-how from previous folks and trying to get that into this product so that folks potentially down the road could use this and move the yardstick forward so that we're not having LiDAR talks about how great just that DEM is, but folks are talking maybe from a different benchmark demonstrating the yardstick can move forward. So in terms of project execution and delivery, we are a one-year project, so we are, I think, one of the shorter ones. We finished, I think, a little bit ahead of schedule, but at the end of the day, we're doing software development. So as a tech company, you know, I've heard a lot of apps and whatnot. There's typically two approaches. Either you plan from the start and create a work breakdown structure, assuming everything stays perfect, which we know often that doesn't happen, or you take an agile methodology and accept that there's unknowns and things that are constantly going to change, and you accept that and you plan accordingly. So nowadays within our space, not just the GIS space, but in spaces in general, it's all about establishing an initial operating capability as quickly as possible. So we don't want to dinker and tither away on reinvent the wheel. The idea is let's get to a place where it's a common baseline for everyone, and then we can have that discussion to say that 20% that we're missing or that's unknown, let's focus our resources there and not reinvent the wheel in terms of what other folks have done. It's almost that 80-20 rule. So Scrum is a concept that you define your requirements. You have something called backlog, and then every fixed period of time, you're picking things and working on them. So instead of doing year-long projects, you're really doing 2 weeks, maybe 3 weeks. Another view of it is pick your different buckets across different sprints, agree on what goes in each of those buckets, and then let the team develop, do their work, research, et cetera. But the idea at the end of each bucket or each sprint, you have something that works. So there's none of this waiting to the end to see if there's success or not. Another important thing in general with our project, and these are principles we applied to our project, was design. So it's kind of a slogan here that really if you have to explain it, then there's probably something wrong with the design. So what happened with this project? So we were heavy on writing code, extending an existing product, and the deliverable was a piece of software. So LTK, a new version, was developed to support the photo point cloud going forward. So ultimately, LTK was extended. As long as it's coming in a LAS format, we don't care. If it's a drone, you know, you're flying a DJI, you know, whatever, you processed it with that type of technology, there's no issues there. So we're gonna do a little quick whirlwind tour of a demo. This is where I'm cueing my AV guys. Again, normally I drive the show, but so they're gonna do a little magic and I will talk through it. I'll try and position myself this way so you can hear me. So that should start playing. You guys got a button? Okay, it is going. So the idea is we created a project. There's things like establishing filter, memory profiles. We'll go ahead and pick the LAS files. So this is all in ArcGIS 10.3.1 right now. You go ahead and pick your LAS files. It complains you don't have a spatial reference system. You go ahead and pick that. Then it goes ahead and then starts analyzing that, creating the spatial indices, the LAS data sets, creates the file geodatabase, and it's spinning its wheels, doing its thing. And the idea here is it's trying to tile the data out into 1K by 1K tiles. So it's very much a divide and conquer strategy. So we'll go ahead and then just create a canopy height model. We're going to build some pyramids or overviews from it. And then as I was preparing this, I realized my screen resolution was all different. So I had to figure out how to do a quick readjust here. And then we tell LTK to go ahead. So the only difference, if we were to handle a SGM point cloud, is we'd specify what the DEM is. So we would simply say, here's the baseline, normalize against that baseline. So that complicated workflow you saw is taking over. So one thing you'll notice about line 5 or something, you'll see that it's splitting instances, splitting the workflow across 7 instances. So we've actually introduced a parallel processing component in ArcGIS Desktop. So I have 8 cores on this machine, so I'm spinning 7 cores and then basically hammering the data set 7 tiles at a point in time. So you'll see that it's kind of whipping through the data set. It's not a small data set. We're still talking probably about a couple gigs, maybe 10 gigs, 15 gigs of data set. So it's not a ginormous data set by any means, but it's trucking along. One thing you may have noticed as I was picking the parameters, I chose a CHM. I didn't specify to create the DSM or DEM. The easiest way of creating the CHM is to subtract the DEM from the DSM. LTK is smart enough to know the dependencies across different predictors. So it's already gone ahead and done that. It's calculated those intermediate products that it's aware of to create the final product. And at this point, we're really just going through and generating the overviews. This is back to vanilla ArcGIS processing, so nothing fancy here. So it finished reasonably quick. So, not a huge area, but there's your canopy height model produced in a matter of a few minutes for that area. We can go ahead and zoom in. It's a canopy height model. You can symbolize it however you want. You're within an ArcMap environment. We can go pick a tile. Then maybe we might want to ask other sets of questions at this point, whether it's show me all the trees based on a certain algorithm. This is based on Dr. Soren Popescu at Texas A&M's algorithm, the tree vol algorithm. And it just quickly segments or identifies candidate tree points, and it reports the crown diameter. And then you can do a host of other things at that point. So just a quick really demo just to show you how the power of LTK, to give you a sense, we can process 3 million hectares in about less than a week type of thing, even quicker than that. So again, the volume of data, it's not big data because big data has volume, has veracity, has a variety of sources. It's either the 3 Vs or 4 Vs. This is just pure volume of data. Oh, they're getting me forward back to where we are. The neat thing about LTK, it's within an ArcMap environment. So a lot of folks really like it because you don't need to write command line and you're in an environment that you're intimately already familiar with. It's leveraging all the existing technologies. So what did we achieve through this project? We did hold a knowledge transfer workshop. In fact, it was in this room, reverse. I think we were presenting from that corner, so it's kind of neat to be back here. We held it November 25th, 2015, so almost 2 years ago. We prepared the training workshop. We invited folks over to learn about LTK, gave them some test data sets and how to actually process that. And I think some folks in the room were actually present at that workshop. We drew in about 26 people, and you can see the spread. We had quite a wide range. We had folks come in from as far as Western Canada and whatnot. And then ultimately, all the registration fees we collected, it wasn't a money grab or anything. It was donated to Forest Without Borders so that they can do what they do and leverage that. So it was a really good, successful meeting, and it brought the community together to exchange ideas and look at where you might take LTK further, which in fact over the last 2 years it has extended even beyond that to include integration with random forest and R. So for those who are big on doing that, you can just run it at LTK. There's no issues there. Obviously, there's a host of other things from a technology point of view to talk about LTK, but for the purpose of this KTDD project, this was kind of an overview of what was accomplished. So for me, the biggest question I know when I was talking with Shelley early in planning this was, the measure of success. Did we achieve our goals? For me, when we started this project, really the key goals were who's going to use this and how much are they going to process, right? So if we develop this thing and then it sits there collecting dust, arguably probably not the best use of FFT dollars. We obviously missed the boat somewhere. Maybe didn't do enough outreach or tech transfer or whatnot. But at the end of the day, that was not the case. So if you look on the left, we do have adoption in the public sector. So certainly at the provincial level, Murray Woods was a key proponent, a push on that. On the New Brunswick side, again, Adam Dick, there should be no surprise. These are some of the leaders in the space at the provincial level pushing the use of inventory. I know Adam uses LTK regularly to prep when he's doing his inventories out for the entire province of New Brunswick, and as well at the Canadian Forest Service level, Joan Luther out east and Jamie Farrell out in Fredericton, in Corner Brook and Fredericton. Of course, on the industry side, I would say is more exciting. There is a lot of adoption. So Mondi in South Africa uses it regularly for their Edunii plantations down in South Africa, Miller Western as well out in Whitecourt, Alberta. And these are out in Western Canada. These are folks crunching like 2-3 million hectare forests. So it's not little areas per se. And then there's a host of the question marks of other folks that choose not to be disclosed in terms of who's using it. In terms of processing, LTK amongst this community is probably being used for probably 30 to 40 million hectares of inventory, area-based inventory generation alone. So again, it is a mature tool with good traction, adoption in industry. It's not something that's kind of vaporware that has gone off. It is actively used. So where do we go from here, I guess? I know in the theme there's a bit, what are some other things, call-outs, and whether it be FRI related or something else. These are just some of my thoughts in the context of LTK. Again, for those who know me, know I can ramble on multiple things, but feedback from folks we've had are people saying, it's great in an ArcGIS environment. I get that. I know how to work there. Can you give me some tools like classifying ground or doing some things that vendors typically might do because the users want to tweak things just a little bit. Individual tree extraction classification, so you kind of saw one example, but some users are saying, there's a truckload of literature out there. Can you suck that into LTK so I, as the forester, can do my tinkering and muck around and simply be able to say, this is so-and-so's algorithm, this is so-and-so's algorithm. Stand auto generation, so this is something that's generated quite a bit of interest over the years. There's been involvement at the federal level, at the provincial level and whatnot, but the idea is how might you use some LiDAR data and other types of data to objectively create the first cut of what stand boundaries are. So we saw in the previous speaker breaking things based on fiber quality. The LiDAR data itself in an area-based inventory is telling us something about what's there. So maybe you can generate something and pass that to the photo interpreters as a first cut to help them go faster or give them a different view. I always say it's great to have multiple arrows in your quiver. You as a subject matter expert, you figure out which one you want to use, and ultimately it's your choice. We're not suggesting we're trying to replace your job, but give people more tools in terms of what you're doing. And of course, the obvious one is moving LTK off the ArcGIS desktop platform into the ArcGIS Pro side. So for 64-bit computing, leverage truckloads of data or RAM, I should say, on your computer and whatnot. So that's a logical progression. We've had a lot of people push us, certainly people doing data processing. And then the themes around how do you share data. If you drank the Esri Kool-Aid, there's magical tools you push, and voila, they're in ArcGIS Online, available for anybody and everybody to consume, etc. So there's a couple ideas on the LTK side of going forward. So certainly, as I wind down, as I said, I didn't want to get into the super technical side as opposed to taking on a journey in terms of what we did with this one-year project. Certainly, acknowledgements are due to Forestry Futures Trust for the financial contribution. As well, we secured financial contribution from the Canadian Wood Fiber Centre. On the in-kind side, we had TEMVAC as well as the M&R involved, as well as the Canadian Institute for Forestry. So on that note, hopefully that gave you a whirlwind tour of what our project was. You got a quick preview of what LTK was in terms of its speed, how it generates things. If you're interested in LiDAR predictors, you're interested in creating Forestmetrics, those are all things you can wrap into LTK and switch out the source, whether it's LiDAR, photo point cloud, whatever it is. So on that note, I will wrap it up and turn it back to Shelley there.
Are there any questions for Dr. Lim?
I guess I'll ask the obvious industry question, how much? What does it cost if I'm a company that wants to implement LTK?
Yeah, so right now, folks are buying it for $10,000 for a license.
Is that per computer, per site?
It's tied to a workstation, so if you're doing a lot of crunching, you basically multiply out, but the flip side is if you have time to wait, you can wait, so.
Any more? $10,000 isn't bad.
Sounds good. Thank you.
Thank you, Dr. Lim. Most intriguing.